Organic molecules often appear as a chaotic tangle of lines and symbols, with branches and groups seemingly placed at random. These drawings are not random. They follow a rigid system of chemical grammar. Every bond and atom has a specific, predictable place within a name. In 1919, the International Union of Pure and Applied Chemistry established a standard formula to organize these structural features. Every name is built by combining 4 parts: the prefix, the root word, the primary suffix, and the secondary suffix. Populating this equation provides a universally recognized way to communicate the arrangement of atoms in most common organic compounds. We can see this formula in action by applying it to this specific molecule. Step 1 is identifying the parent chain to find our root word. In this structure, there is a continuous path of 4 carbons, giving us the root bute. It is a common mistake to simply choose the longest carbon chain. The parent chain must include the multiple bonds and principal functional group. Step 2 is identifying this group for our suffix. Here, the OH alcohol group gives the suffix "all." If a molecule contains several functional groups, we use a priority list to choose the suffix. A carboxylic acid outranks an aldehyde, and an aldehyde outranks an alcohol. The group with the highest priority determines the end of the name. Once you have identified the parent chain and the highest priority group, the core identity of the chemical name is established. Step 3 is numbering the parent chain. We have 2 options, starting from the left or from the right. We apply the lowest locant rule, starting from the end closest to the principal functional group. Here, that means counting from the right. This sequence determines the coordinate for our primary suffix, the double bond. Step 4 is identifying substituents for our prefixes. We have a 1-carbon branch, a methyl group, we identify this as 3-methyl. If the molecule had multiple identical branches, we would group them together using multiplying terms like di for 2 or tri for 3. Using these coordinates ensures the written name corresponds to only one specific molecular arrangement. Step 5 is organizing the prefixes in alphabetical order. When sorting alphabetically, we ignore the multiplying prefixes like di, tri, or tetra. We compare ethyl to methyl by looking at the E and the M, bypassing the di entirely. Finally, step 6 is the assembly. We combine all our identified parts into a single name using strict punctuation rules. In this system, commas are used to separate numbers from other numbers. Hyphens are used to separate numbers from words. Following this syntax allows a list of structural components to be read as a clear, standardized blueprint. Now we can return to the structure that appeared intimidating at the start. By applying the 6 steps in order, identifying the chain, prioritizing the group, numbering the carbons, locating substituents, alphabetizing, and punctuating, the structure is identified. This framework is the same system used by chemists globally to ensure their findings are understood without confusion. Here is a new structure. Try to find the parent chain and identify the substituents using the rules we've covered. When you approach a molecule as a checklist of steps, the name becomes a direct result of the structural evidence. Once you have your answer, leave it in the comments below.